Hey guys, Afshin here, and welcome to part 3 of the VEX Onshape tutorial. So last time we covered some of the simple assembly mates, so like the fasten mate, revolute mate, slider mate, planar mate, and cylindrical mate. But today we're going to step it up and look at some of the more complex VEX specific mates and advanced features in some of these mate tools that we didn't talk about before. If you haven't checked out the rest of the series though, I definitely recommend it, but for now, let's jump right into it. Alright, so like I said before, we're going to go through some more complex VEX mates. So to start, we're going to go with the pin slot mate. Now the pin slot mate is basically, as it shows up here, just a left and right slider mate. So while the regular slider mate is forward and back, the pin slot will go more left and right. So if we create a mate connector here and attach it to the gear, or attach the gear to the C channel, then flip it because we want it on the other side, exit out, and fix it, the C channel. Now we can see this gear is able to go left and right across the C channel. We can also see it's able to spin. So if you want something to be able to spin and also move left and right, it's good to use this. Another note though, that if you don't want this to spin, you don't have to, and it's fine with or without. Anyways, on to the next mate. So this next mate, the ball mate, is a mate that you don't really use for VEX. However, I still think it's a cool mate to know about. So like for example, we can connect one mate connector there and one mate connector here, and then select it. And if you look at this now, you can see that this is able to move any way, like kind of like a ball around those mate connectors. But like I said again, this isn't something that you could really do feasibly in VEX just because of the way that VEX parts is designed. Maybe it's something you could try in the Rec Foundation competition, and it's definitely something that you can use for FRC. Anyways, next, one of my favorite mates is parallel mate. So parallel mate comes really useful in very specific times. So for example, say you want these to be straight, but you accidentally, like, say angled this one. I'm gonna unfix that real fast. You angled this one at a weird angle, like 102.373. So now it's hard to make it like straight again because it's hard to just line up the angle perfectly. Like even this isn't exactly correct, especially if you forget the exact degree that you adjusted by. So an easy way to get by this is to fix the part that you're trying to make it parallel to, and then create a parallel mate from any of the faces or sides to another face or side, the ones that you want parallel, of course, and then check it, and voila, now this thing is parallel. This also makes it so that this can't rotate though, because if you were to rotate it, it wouldn't be parallel anymore. However, if I were to unfix this, now it would be rotate, and now it would be able to rotate, and it would rotate both of them at the same time. So one really good use of this especially is in DR4Bs, where you want this, if this was the stationary side with the motor, you want your left side to move up and down vertically, and not be tilting or angling at all. So that is one really good example for using that. Anyways, on to the next few. So the tangent mate and width mate, I'll be very honest, I've never used them before, never needed to use them before across just general CADing for my own projects at home, FRC, underwater robotics, and VEX especially. I've never needed to use these, so I wouldn't really worry about these that much. But anyways, next let's go to group. group is a very, very, very important mate, as it lets you to kind of cut down on your mateage resources, because the more mates that you have, the more that your computer needs to load, and it makes it harder to run these complex CADs, especially when you're running it just on the internet. So I'm going to cancel this and then insert a screw and a nylock. So yeah, you can insert a screw and a nylock, and say I wanted to connect these two together and model that in CAD, because for whatever reason I needed to connect two C channels together. So what I could do is I could mate like that, and then I want it to be flipped and be like that. So then keep in mind, each time this little bubble pops up, that's the S key, so to access all the simple mates. But you can click that, and then I'm just going to create a quick fasten mate connector to this to the two C channels. Okay, so now we have these two C channels connected, but say we wanted to connect them differently so that it looked like this. And in this case, you'd want more than one screw. So while you could just go and copy paste and go and individually try to go like fasten each of them, that would take a lot of time. So instead, what you could do is you could select these two and copy paste them, and then make sure not to move them, because then that would change how they're like connected. But you can use a group mate, highlight both of them, and now you have this little group mate. And what this means is you can copy paste the group mate. So Control C, Control V, and now when you move one, it moves both. So this is really nice when you need to put a lot of screws on your CAD, because say you're trying to like CAD something exactly. So you can utilize this tool. So all you have to do is copy paste and put it in. So it essentially decreases your CAD time by 2. Keep a note, in the future I will be going over tips and tricks to decrease your CAD time and tips and tricks to have Onshape run better on your computer, so be on the lookout for those. But anyways, let's go to the next few mates. So these next two over here aren't exactly mates, but there's still different features that's important to use. So one is snap mode. Snap mode, I would say, I haven't found too much uses of it. What it does is you select it, and you can select any piece, and any piece that it's mated to will automatically get this translucent type vibe. So if you're in a big assembly and say you needed to see this brain that is behind the C channel, give it a second to load. You need to see a brain behind the C channel, but you can't see it too well because there's a bunch of C channels in the way. So then what you could do is use snap mode and select anything, and it would make it translucent, and by making it translucent you could see through it. So it's a really easy way to just like be able to see through things. But next is the show mates mode, and the show mates mode, what it does is essentially whatever you hover over, it will show the mates for it. So like for example, I'm hovering over the C channel, and right now it's showing the mates from the screws and the nylocks and the groups. So that's really useful if you're like trying to find a specific mate and you don't want to show every single mate, because there's a feature over here. If you right click any mate, you could show a specific mate, or you could show all mates. But say you don't want to show all the mates, or you have a bunch of mates and you can't find them, then you can just click show mates, go to the piece that you want, and you can edit whatever mate it is from there. So it's a really nice, easy way to access mates. Okay, other than that, for these two, I would say that I've never actually used this one, I've never seen too much use for it. So you should be relatively fine without using replicate. Honestly, there's some other features I'm going to show you that will outdo this feature. So anyways, next is the replace instance. So this one comes really nice in a clutch. Like for example, say that you needed all of these screws, or you wanted all these nylocks to instead be screws. So you could say replace all instances and then select the nylocks, and then say you can change those nylocks to caps nuts. So there, no, it's not in there. To caps nuts. So then we can just select caps nuts, and it'll automatically select caps nuts. But as you can see, the mates over here broke. So since the mates broke, what you have to do is you have to find the errored mate and then refix it. So once you refix it, then it will break all the other mates still, but so you need to refix every single one. But in most case scenarios, as long as you plan beforehand what you're going to use, you don't need to use it. But when you do need to use it, like say for example change a 2-inch flex wheel to a 1.625 inch flex wheel, it's really nice. Anyways, next we have our assembly linear pattern. So actually I'm gonna bring these back and I'm gonna delete those. Actually no, let's put it back as an nylock. Okay. So remember how we were copy pasting the groups beforehand? A nice feature that you can do that would be even a little faster when it comes to straight lines and even squares is a assembly linear pattern. So what this does is it will take any instances. So like for example, in this case, the screw and the nyllock, you can choose a direction by clicking any line. So if I were to click this line, the direction would be up and down, but I wanted to go left and right because I wanted to go along the C channel. So I click a left and right line, and then you can say how far we want them. So say we wanted them 1.5 inches apart or 2 holes in between, and then just set how many you would want. So say we wanted to go across the whole C channel, then that would be about 6, I believe. No, that would be 12. Yeah. So then you'd have it go all the way across, and that's a really nice way if you need a lot of things in a little place. And this, I would say this is one of the most useful, but definitely not the most because there's still more. So we'll delete that. And next we have the circular pattern. Now this is just about the same thing as this, except it's a circular version of this. Now since VEX is mostly linear when it comes to things, you typically don't need to worry about the circular pattern unless you're trying to add screws and stuff for plastic, which in that case it would be nice, but either way, I'm gonna show it to you guys. So you have that, and then you need to set your axis. So to set your axis, that's essentially where everything's going to rotate about. So you want to choose a vertical line like compared to it. So for example, if I wanted it to spin around here, then I could choose this vertical line and set how many I want. So like say I want 10, then it'll go around that axis and it'll create all of those. And then of course you can set how much of an angle. So say you wanted it to only go halfway around, you can set it to 180. And like I said again, this one's not as useful unless you're doing it for plastic, just because of how VEX works, but it's still nice to know either way. Anyways, next we have our gear relation mates. So gear relation mates are actually very interesting. However, most of the time you don't need them. But I have found one nice use case scenario where I've needed them. So we'll check that out. So what we can do is we'll revolute. You need 2 revolutes to use a gear mate. So I'm gonna clean this out a little bit. We don't need all these C channels. Okay, so we can create a revolute, clicking S to get that dashboard, making a mate connector, and then holding shift, creating that, and then another mate connector, and creating that, and then swapping it, and nice. So now that we have our two revolutes, what we can do is we can create a gear relation. And to select the revolute mates, there's a few ways you can do this. One, you could right click, click any of these mates. So for example, just clicking here and clicking here, that would do it. You could also have these all already set to show all, and then you can click it on the actual feature. Or you can use the show mates mode. You can use the show mates mode beforehand to show it, and then show it there, and then go click it. But honestly, most cases you would have these revolutes right next to your actual gear relation, so it's usually just easiest to use it from the mate bars over here. Anyways, now that we have it, right now we can see that it's a 1-to-1 ratio, but obviously when we look at these are not a 1-to-1 ratio. So if I were to spin it right now, let's fix this. If I were to spin it right now, they're not actually spinning accurately to how they were, how they would in real life. So to fix that, we want to right click and edit it. And right now, we know that revolute, the gear ratio starts from the first revolute that you click. So revolute 2 was the small gear, and the small gear was 12 teeth, and the bigger gear is 36 teeth. So that means the ratio is 1 to 3, since 12 to 36 is 1 to 3. Over here, you can write 12 to 36. But generally it's just more cleaner to write 1 to 3. I like to, but whatever works. So over here, now you can see that it's working as it would normally. So if we spin this, then this spins slower, and if we spin this, then that spins a lot faster. Okay, a few more mates and then we'll be good. Okay, so next we have our rack and pinion relation. This one is definitely not used as much as the other ones, as usually in VEX you don't end up using a rack and pinion. Sometimes you do, but usually you don't. So to set this up, you need a linear mate and you need a revolute mate. So I'm just gonna attach that on there. And then I'm gonna make this one horizontal, and then we can have this one, rack and pinion with a linear slider mate. Sorry, we can have that set to be off of this, and then we want to fix this because we assume that this will stay in place and this will be the one that's moving. And then we can have another C channel, and then set a revolute mate. We want it on this side, and then we can turn this so that it's over here, and then we can line it up nicely. Generally, you would do this just in like when you set everything together. So like you could mate these C channels to each other, and then this one could be floating, or on like a rail, because VEX has a rail system where you can connect this to sliders and use that. But just for this example, we're using these 3 C channels. And then once you have your slider mate and your revolute mate, then you can go to your rack and pinion relation, select these 2 mates, and if I were to click check, I'm gonna rotate these real fast just to be nice. Oh, that one's fixed. So we can unfix, which one's fixed? This one's fixed. So we can unfix that one and select all of these from going from right to left drag, and then rotating all of them by 90 degrees, moving those out of the way. And then once let's fix that back. So this one's supposed to be fixed and this one's supposed to be fixed. So then once you spin this will run like an actual rack and pinion would. However, you can see if you look really closely, this is actually not spinning the same amount that it would spin in real life. Or it's not moving the same amount that it would move in real life. So it's phasing a little bit through the rack and pinion. And to adjust this, you adjust the distance per revolution, which you could calculate. Just for time's sakes though, I'm not going to calculate them, so you can keep this video relatively short. But this is something you can do using Gemini or Bing or Copilot or whatever, or some online calculator. But anyways, for our last important mate, just for notice, these two mates I wouldn't say are too important. You don't really have to worry about them, so don't worry about them too much. I haven't ever used them for, again, either of the programs that I've worked in, so you should be relatively fine. Anyways, the last one is assembly mirror, and I saved this one for last because it is the biggest and most important mate that you're probably ever going to use, besides obviously the fasten mate and probably the revolute mate. And this is because, as it says, it lets you mirror your parts. So say for example you wanted to bring this AI vision sensor onto the C channel, but first you can see that these are multiple separate parts, but we don't like that, so we can group it. And this is something that you're going to need to do with any part that you import. Most of the time it'll come in multiple smaller parts, so you'll need to group it. But once you group it, it all moves at one. Anyways, let's fasten that and put it onto our C channel. Okay, so now we have a AI vision sensor on, say, the left side of our bot, or we can swap it the other way. So now we have an AI vision sensor on the left side of our bot, but say we wanted another one on the right side of our bot, just to be safe and whatnot. So then what we could do is we could use the mirror mate. We could select everything we want to mirror, and then select a mirror plane. So for selecting the mirror plane, what you have to do is you could either select another piece, like for example, say I were to bring this brain here, and if I were to do mirror that, and then select mirror plane, and I select this plane, then you could mirror it across the other piece. However, I find that this isn't really the best way to do it. Normally, what you want to be doing is you want to select everything, assembly mirror, and then instead of clicking mirror plane, you click select mate connector, and then from whatever mirror that you want to be mirrored, you could select a mate connector, and then you can click edit the mate connector and move it however much you want it to be mirrored. So say for example, you want it to be mirrored by about 1 inch. So you could say 1 inch, so it would be 1 inch forward, and then that would mirror itself by 1 inch. And this is really, really useful, especially in drivetrains and in general mechanisms where it is symmetrical, because that means you don't have to have your computer load the whole drivetrain until you're completely finished and you don't have to touch it. That makes you work faster, and then you don't have to wait a bunch for things to load. So it's really nice to work with tools like that. But other than that, there is not much else. So just work on using these mates, and you'll get better with them over time. And other than that, just have fun. Hope you guys like the video. Please subscribe and comment down below, and like, and I'll see you guys next time. Bye.